Okay, here we go. We're doing polynomials, exponent rules number 1. And we're going to start with something we already know. We know that x times x is x squared. So we're going to build on that. We've distributed before. We know x times x is x squared. So let's go ahead and see. We've got a monomial. Oops. All right, we've got a monomial. Hold on one second. 3x is a monomial times a monomial. It doesn't matter. I'm saying monomial. It doesn't matter if you say that or not. We've got something times something. And so when I already know x times x is x squared. And so we are looking at, well, what's 3 times 4? 3 times 4 is 12. And then, of course, we have x times x. And x times x is x squared. All right. So far, we've done things like this when we've distributed, right? All right, here we've got an x and a y. So let's just continue this idea that we're going to break it down into the numbers first. 2 times 5, our constants first. 2 times 5 is 10. And then our x times x is x squared. And then our y times y is y squared. And that's our answer. So right now we're just being asked to multiply a monomial times a monomial. And once again, the words don't matter. Let's see what's behind this. Okay, now, this is where we are going to learn kind of a new way of going about this. We just automatically knew x times x was x squared, right? But here we've got x squared times x cubed. So what we want to do is break this down. X squared is the same thing as what? X times x, right? X cubed is the same thing as x times x, right? And we're multiplying these two. Once again, multiplication, we can use dots, we can use parentheses. So how many x's do we have here? 1, 2, 3, 4, 5. So our answer is x to the 5th. Now, that's a really good way of doing it when our numbers are small. But wonder if this said x to the 20th times x to the 30th. Would we want to be writing x 20 times and x 30 times? No. So we're going to learn that shortcut. And so I think that if we just look at what we wrote, we can see, well, it makes sense there were 2 x's being multiplied here and 3 x's being multiplied here. So 2 plus 3 is 5, and that's how we got our 5. So that's our first rule about exponents. So let's do that again. Here, once again, we've got our numbers. The same rule with our numbers, right? When we've got numbers, 5 times 6 is going to be 30. There's no new rule there. But when it comes to our x's, what we're going to do is we see that our x, and when we look at exponents, I should have just kind of stopped and said this. Let's just take x cubed right here, right? This part right here is called our base. So if we're multiplying and the bases are the same, what we do is we write our base down, and then we add our exponents. And you're like, Ms. Overby, wait a second. This first one doesn't have an exponent. And you're right. That x, we're going to put to the first power. We've been doing that a lot when x doesn't have a number in front of it, we're putting a 1. Well, now we're going to do the same thing when x doesn't have an exponent, we're going to put a 1. So when we're adding these, we've got what? We've got 1 plus 3 is going to give us 4. All right, so we're doing something new. And once again, the rule for the numbers is always the same. There's nothing new going on with the numbers. So let's look and do the numbers first. So we've got negative 2 times 8. That's going to be negative 16. No new rule there. But when we come to the x's, and I'm going to put a 1 there for the x to the first power times x to the second power is x to the 1 plus 2 is 3. So that's our new rule. Let's go ahead and look at our y's. Y to the 4th power times y to the first power is y to the 4 plus 1 is 5. So this is what we're going to be working on today, is just multiplying our monomials, multiplying polynomials, if you don't want to say monomials. All right, so the ones on Delta Math are going to look a little bit more, I don't know, complicated, but they're not. It's the same thing. All right, so here we've got 6 times 13. I realize I don't have a calculator, so let's see. 6 times 10 is 60. 6 times 3 is 18, so that's 78, right? Does that make sense? And then we've got our x to the first, x to the fifth. So x to the first times x to the fifth. We write our x, and we add 1 plus 5 is 6. We're done with our x's. And now let's look at y. We have y squared times y squared. We write our y. 2 plus 2 is 4. And we're done. Okay, we're going to practice this and practice this. And the reason why we're going to practice this is that we use this kind of math all the way all through calculus. So we just want to be good at it. Algebra is a lot about just practicing. All right, we notice something. I see a negative 8 here, but I don't see a number here. All right, we can put a 1 here. Always. You can always put a 1 there because we have 1x squared, right? So 1 times negative 8 is negative 8. Then once again, we're going to focus on our x's. We have x squared times x to the 4th. So that's going to be x to the 2 plus 4 is 6. And then we've got our y. We've got y to the 5th times y to the 3rd. So that's y to the 8th. This is what our delta math problems are going to look like. We can do them. Just remember that the rule for the numbers, it's always the same. Like for this, negative 12 times 2, that's always going to be negative 24. No new rule there. Uh-oh, we noticed something. Here, we've got an x, and here we don't have an x, right? We don't see an x. So that's okay because no x times x is just x, right? And then we've got y. We've got y in both places, right? We've got y to the 3rd and y. Once again, we'll put that 1 there. So that's y to the 3 plus 1 is 4. So the new thing here for this problem was to remember, if we don't have, like, say we were missing that x, we just rewrite the one that we see, all right? All right, let's see if there's anything else. That's it. We did it. All right. Really, 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 we learn by doing. So all this practice that you're going to be doing on delta math, that's your way of not only learning, but retaining it, which is super, super important. All right. Thanks for joining me.